So far, I showed how active safety is all about making a vehicle intelligent enough to recognize critical situations and take actions. To do that, a vehicle needs to be aware of its surroundings, process this information, and act, either by alerting the driver or by braking or steering automatically. The eyes of our vehicles are sensors and include cameras, lidars, radars, and other sensors which will be presented in another lecture. The brain of our vehicle is made of algorithms for threat assessment, understanding the criticality of a situation, and decision-making, determining the time and timing of the intervention. Finally, this intervention typically requires some muscles, a human-machine interface to inform or warn the driver, or actuators for automated braking and steering. Active safety systems that prevent rear-end crashes, such as the ones shown in the video, are often classified as longitudinal control systems because they support braking and in some cases accelerating also. Examples of lateral control systems often include lane departure warning, lane keeping assistant, and lane change advisor, which are more concerned with steering. As active safety systems become more integrated and automated, they may combine longitudinal and lateral control. An example is the Pilot Assist system from Volvo. Pilot Assist combines two systems, one for longitudinal control called Adaptive Cruise Control, and one for lateral control, which provides steering assistance. Both these systems offer sustained assistance. In other words, they offer a continuous support to the driver to facilitate the driving task. Let me show you a video that explains how a system in longitudinal and lateral control enable Volvo Pilot Assist, a system that provides automated driving at a low level.
Pilot Assist function. Pilot Assist is a support function that will help you to drive your car in the middle of the lane, halfway between the visible road lines at the sides. It will also help to maintain an even speed and a pre-selected distance to the vehicle ahead. Pilot Assist acts by adding gentle steering input as well as adjustments of braking and acceleration of the vehicle. It is important to remember that the steering capacity of Pilot Assist is limited. You must steer the car in the right direction when entering a sharper turn or to avoid obstacles on the road. Pilot Assist works best on dry motorways with clear lane lines. Allow some time with the Pilot Assist to get comfortable and familiar with the help the function is offering. If the visibility of the lane lines is poor due to rain, snow, or dirt, you may want to switch off Pilot Assist.
To conclude, as we may be getting closer and closer to an historic turning point for automotive travel, it is worth noticing that active safety is currently delivering low levels of automated driving. Further, the basic technologies currently in use for active safety systems are the same that will be employed by automated vehicles. So, to recap, in this lecture I pointed out impaired driving as a major cause of road crashes. Then, I explained how active safety may support drivers by recognizing safety-critical situations and take action. I also mentioned how active safety systems may use different intervention strategies. Then, I presented the main components of an active safety system and showed some examples of commercial systems. Finally, I pointed out how current active safety systems deliver low-level automated driving already today. This concludes this lecture on active safety. Please take now a look at the references and at the self-assessment. I hope to talk with you soon in another lecture related to my research at Chalmers.